In this section, we'll look at our third type of factoring, which is factoring polynomials in this form. And the key here is the coefficient of the x squared term, which is a 1. It's 1x squared. So before we do that, let's return to the chart that we've been working on about how to recognize the factoring types. So this type of factoring we call trinomial, and we're going to call it the short process. That's just my little kind of nickname for it. And when I say that, all I mean is what I just said, and that is that the squared term has a 1. The number of terms, obviously, if it's called a trinomial, must be 3, and the answer also looks like FOIL, just like it did with factor by grouping. So let's look at how this works. If you'll recall the FOIL process, you have two binomials being multiplied times each other, and what we do is we say first, outside, inside, and last, and then we combined like terms, so x squared plus 4x plus 3. Well, the type of factoring that we're looking at in this video, what it does is it takes an answer like x squared plus 4x plus 3, and we're going to unravel it back to what it looked like before it was ever FOILed. And it's really a real simple process for doing it. It's not just a guessing thing. So let's take a look and I'll show you that process. We want to factor x squared plus 7x plus 12, meaning we want to get it back to what looks like a FOIL problem. So here's how you do it. You take the last term with its sign and you say, I'm looking for factors of positive 12. Make a little arrow to the right. Make an arrow down, and we want those factors, meaning when they multiply together they make positive 12. When they add together, now take the middle coefficient, they make positive 7. And please hear this, it is essential that you show the signs. You will make mistakes if you don't. Just trust me, you must show the positive or negative. So I want two numbers that multiply together to make positive 12, and when I add them they make positive 7. So let's think about numbers that make positive 12. Positive 12 times positive 1, positive 6 times positive 2, positive 4 times positive 3, negative 4 times negative 3, that still makes a positive 12, negative 6 times negative 2, and negative 12 times negative 1. They all multiply to make positive 12, but only one set of them also does double duty and adds together to make positive 7, and that is positive 4 and positive 3, and that will always be the case. There can be a long list of factors that make this, but there will only be one set that also make this when you add them. Once you have those two numbers, all you do is make your FOIL parentheses. To get x squared, when I do first times first, I need x times x. And now I'm just going to write these two, and it doesn't matter the order. Plus 4 plus 3, or you could do it like this, x plus 3 plus 4. It's still going to FOIL to be x squared plus 7x plus 12. And of course you would want to FOIL it to check it. That's why this is called the short method, is because once I find those two numbers that multiply and add to make our given, then you basically have your answer. Your answer will always look like a FOIL. So let's try another one. X squared minus 12x plus 35. Remember, the signs are critical. So I want numbers that multiply to make positive 35. That's my last. But when I add them together, I have to get negative 12. Now, let's think about, to get a positive, you have to have a positive times a positive or a negative times a negative, right? I showed you that up here. Well, which set do I need if when I add them, I need to get negative 12? It has to be a negative times a negative. So I know I need two negatives. So I'm looking for two numbers that multiply to make 35, but they add to make negative 12. I believe those are negative 7 and negative 5. Think about it. Multiply, you get positive 35, negative times negative, but add, you get negative 12. So I go straight to my parentheses and I have them, x, and then negative 7, negative 5. Those are my factors. I personally think this is the easiest of all the factoring, this short process trinomial. So look at this one, a little bit harder. I need factors of negative 12, include the sign, that add to make positive 4. Here's what makes this one harder. To get a negative answer when you multiply, you need a positive times a negative. I know that. But to add them up and get a positive 4, that means I have to have more positiveness than negativeness. So I know that the bigger number has to be positive. So watch. If I multiply those, I definitely get negative 12. If I add them, because the bigger number is positive, I get positive 4. If you thought it was this, those definitely multiply to make negative 12, but when I add those, I do not get positive 4, I get negative 4. So the only ones that work are those two. So again, it's x plus 6, x minus 2. And yes, as I just showed you, it matters which one is positive and which one is negative. So that makes it a little bit harder. Let's look at number 4. I need factors of negative 42 that combine to make what? Negative, think about the implied coefficient, a negative 1. So once again, I know I need a positive and a negative. But in this case, when I add them, I end up with negativeness. So the bigger number has to be negative. So I believe this is what we have. 6 times 7 is 42, and a positive times a negative makes a negative. When I add those, there's more negativeness. I get negative 1. So it's r, I think those are r's, not t's. Yeah, r minus 7, r plus 6. That is short trinomial factoring. Let's try another page of them with some that have a few little idiosyncrasies. So let's look at this first one. A squared plus 2a plus 10. I need factors of positive 10 that add up to positive 2. To get a positive, it's a positive times a positive or a negative times a negative. But if I have a positive down here, I know it's going to be this. So what two numbers multiply to make 10, but when you add them, you get 2? Well, we could have positive 10 and positive 1. That makes positive 10, but it doesn't make positive 2. Positive 5 and positive 2. That makes positive 10 when I multiply, but it does not make positive 2. And those are my only choices. So what does that mean? It means that this is not factorable. It is what we call prime. There are no two numbers that fit those parameters, so it can't be factored. Now that's not going to happen very often, so don't count on that. In fact, it will not happen on your test. Here, this one looks different because we have something extra on the end. We have an extra variable. Doesn't matter, still works the same way. We're looking for factors of positive 6 that combine to make positive 5. Well, I'm pretty sure that's positive 3 and positive 2. So when you go to write your factors, I know on my first FOIL, to get x squared, I need x times x. And I know then that I need a plus 3 and a plus 2. But how do we get that y squared on the end? You put the y's on the end of your factors. And on this one, I'm going to FOIL it out to show you how that works. So let's do that in a different color. So if I FOILed it to check it, which you always should do, I would have x times x is x squared. X times positive 2y plus 2xy. Positive 3y times x plus 3xy's, and positive 3y times positive 2y is plus 6 y squared. So that's how I got that. My middle terms are like terms, and that is how I get my 5xy. So it does check with what we had originally. So if there is an extra variable squared on the end, you're just going to split that and stick it on the end of each factor. All right, let's look at this one. What's different about this one? Well, what's different is this isn't x squared, it's x to the 4th. And this isn't x, it's x squared. Works the same way. I still want factors of positive 6 that combine to make positive 5. Same as up here. It's still positive 3 and positive 2. So when I go to do this, I know it's going to be positive 3 and positive 2. But how do I get an x to the 4th on my first term? It's when I take x squared times x squared. So that one's a little different that way. And also then when I multiply, my outside is positive 2x squared, my inside is positive 3x squared. So that's going to take care of that middle term also. So just a little idiosyncrasy. This one also has a little idiosyncrasy, and that is that the coefficient of the m squared is not a 1, and I said that it had to be in order to use the short process. Well, this one is a combination factoring. If you will look at the three terms, 3m squared minus 24m minus 60, there is a GCF, something that we can pull out of all three. So this is a GCF plus a short trinomial factoring, and I'll show you how. What goes into all three is a 3. So if I first factor out a 3, I'm left with m squared minus 8m minus 20. I divided 3 into each of the terms. Now what's in the parentheses is also factorable. Let's do that in a different color. Now I have a 1 in front of my m squared, so I'm looking for factors of negative 20 that combine to make negative 8. Now I know to get a negative, I need a positive times a negative, and to have negative leftovers, I know the biggest number has to be negative. Let's worry about the signs at the end, and let's just find the factors of 20. We have 20 times 1, 10 times 2, and 5 times 4. With the bigger one being negative, which one of those adds together to make negative 8? Because I know they all multiply to make negative 20. The only ones that make negative 8 are right there. So this part of my problem is going to be m minus 10, m plus 2, but we're not finished until we bring this GCF down and it becomes part of our factoring. So if you were going to check this, you would FOIL this part, you would FOIL that, and then you would multiply whatever you got times 3, and it would check. So you can have combinations of more than one type of factoring. And looking back at our chart, it's common to first have to factor out the GCF and then do one of the other factor types. And you'll see some more examples of that in other videos.